Hey everyone, let's take a look at this question with regards to the tree diagrams that we're working on. And I want to just take a moment to kind of explain this. So I've used some numbers here that I think will make a little bit more sense when we look at the whole picture. So here's the situation. In a class, 80% of students are wearing long sleeves. Of students wearing long sleeves, 25% are women and 75% are men. The short sleeve students are split evenly 50-50. All right, so that's our setting there. I made a little chart down here, and I want you to recognize in here the way that I did this. Here's my long sleeve students, 75% male, 25% female. My short sleeve students are 50-50. All right, what I haven't put on here is the fact that 80% of students are wearing long and short sleeves. So let me show you how this works in a tree diagram setting. So here is my first part of this decision, and it's 20% female, 20% short sleeve and 80% long sleeve. That's these numbers up here. 80% students are wearing long sleeves. So here's my long sleeve and here's my short sleeve. All right. Once I go to the next step, of these 80%, it's split 25 and 75%. So this is female and this is male. Over here I have the same thing, but it's split 50-50, female and male. All right. What I want to do is, since I use these numbers, I want to put some actual numbers in here just so that we can see how these things work. Let's say that my class had 10 students. All right, so I've got 10 students in this class. This should make it pretty obvious that I have 8 students over here and 2 students over here, 80% and 2. And then if I split these students in half, I have 1 girl and 1 boy wearing short sleeve shirts. Long sleeve shirts, 75% or 3/4 of 8 ends up being 6. So I have 6 male and 2 female. I actually have these backwards. Oh no, 25% are women, 75% are men. So that's correct. 6 men wearing long sleeve shirts, 2 men wearing short sleeve shirts. Okay, so I did that so that we can kind of come back to those numbers, since it's easy to distinguish what these are. We come back to those numbers later. So what I want to focus on is a few of these questions. What is the probability that as a student is a male wearing short sleeves? Just so that we see what this looks like. This is the probability that a student is a male and wearing short sleeves. All right, so I usually use this as the symbol for, I'm just going to do it like this, male and short sleeves, since we're probably more used to it. In fact, let me erase that. The U that you sometimes see is the union, so you'll sometimes see that in statistics. I'll just use this. So male and short sleeves. What is the probability that a student is wearing short sleeves given that it is a male student? That is a slightly different probability that they're wearing short sleeves given that they're a male. And this one, what is the probability that a student is a male given the fact that they're wearing short sleeves? All right, so I want to take a look at each of these and see how they're similar and different and what the numbers are for that. So let's start with this. What is the probability that as a student is a male and wearing short sleeve shirts? So really for us to do that, we're just looking for where this line comes in. It's like, well, here's short sleeves and male. All right, so I already know that there's 1 student, but how do I get to that 1 student? Typically we take 50% of 20% of whatever number I have. So normally I would say the probability is 0.5 times 0.2. All right, and that equals 0.1. So I ended up, if I were to know the number was 10, I'd have 0.1 out of 10. So probability that a student is male and wearing a short sleeve shirt. All right, and remember when we're taking a look at that, that is really done like this. Probability that you're a male times the probability that you're a male given the fact that you're wearing short sleeves. So probability that you are male is 50% when oh, excuse me. So that was really done by doing the probability that you're wearing a short sleeve shirt times the probability that you're male given the fact that you're wearing a short sleeve shirt. That's the general rule of multiplication for probability that you're male and a short sleeve shirt. So that was 0.2 times 0.5. That's where those two numbers I got before. So that was the first part that we had there, and that gave us 0.1. So got that down there. So now let's move on to question number 2. It's a little bit different. What is the probability that a student is wearing short sleeves given that it's a male student? All right, so if I'm looking at just the numbers here, I know that I have 7 male students. Okay, and basically all I did was I added this student to this student. So there's my 7 male students. All right, so probability that you're a male is really 0.7. Now, how do we get that 0.7? This is where a lot of times when we're working at this, I want to know what these individual numbers are down here. So let's write them in here. I'm just going to crunch the numbers for you. So I know this one is 0.1. I already did this. All right, we did it right there. This one is also 0.1. Multiplying these two numbers. 75% of 80%, I'm gonna grab a calculator here, should be 60%, and it is. And 25% of 80% should be 40%. Oh, excuse me, not 40%, 20%. So all of these were just calculating short sleeve and female, short sleeve and male, long sleeve and male, long sleeve and female. And when I say and, just like we did this one, I'm just multiplying these two things, kind of going through and saying, so there's the probability that I am male ends up being these two. All right, so 0.1 plus 0.6. So that was the probability that I'm male. So what is the probability the student is wearing short sleeves given that is a male student? So what I'm really asking here, since I'm doing that, short sleeve, given that it's a male student, if I break this one apart, I'm really looking for this. Probability that they're short sleeves and male divided by the probability that they are male. All right, I have these numbers already. Probability they're male, we said there's 7 males, 70% of 10. We also did it with the numbers here, 0.1 plus 0.6. So I have 0.7. That's what this ends up being. That's my probability that you're a male. Probability that you're short sleeves and male, that's what all these green numbers are. Short sleeves and male is 0.1. So I end up with 1/7 or 14%. Now, the reason I'm choosing these ones is I'm doing all of these that have the same notation. So you'll notice short sleeve and male. I did probability that you're short sleeves given the fact that you're male. Now I want to see what's the probability that you're a male given the fact that you're wearing short sleeves. And I want to do it the same way. And you'll notice because of some of the things I know, it's sometimes a little bit trickier here. All right, so let's break this one apart. Probability that you are male and wearing short sleeves divided by the probability that you are wearing short sleeves. All right, so we've got those things. We've done this already. All right, if I say was probability a student is a male given the fact that they are wearing short sleeves, well, I know there are 2 people wearing short sleeves and one of them male, so I know it's 50%. But now let's see how we get there with the statistics and with the probabilities. Male and short sleeves, just like we did up here, male and short sleeves, 0.2 times 0.5, so that's still 0.1. All right, the probability that you're a short sleeve, well, there it's just written there, divided by 0.2. So I have 1/2 or 50%. So hopefully you notice a couple of the things are just really being reworded from the question. Number 3, probability of students male given that they're wearing short sleeves. It says right here, short sleeve students are split 50-50. I can do the math, or I can just interpret the question and say it's a 50-50 chance. Probability that a student is male wearing short sleeves, well, that one is just putting them together. Male and short sleeves. We put them together by multiplying these, 0.1 times 0.2. We ended up with our 0.5 times 0.2, half of them. And then same thing here. Now, I put those numbers in here so we could go back and look at them. So let's just take a quick peek at what this says for how many. And you have to remember to interpret the question correctly. Probability that a student is male given that they're wearing short sleeves. I have half of 2 people, so that there tells me there is 1. And that's how many people I have. That's 1 male wearing short sleeves. Probability that is a male wearing short sleeves, 1/10, tells me that that's 1/10 of 10. That's 1 student. Again, there's my 1 student. Probability that a student is wearing short sleeves given that they are male. Normally I would say, well, it's 14%, but what's it 14% of? 14% of the 7 students that I have here, and 14% of 7 is 0.98, which is rounded off to 1. There's my 1 student. The answer to all of these questions is this male student wearing short sleeves, but notice the different percentages because of the way that you ask them. All right? Whether you know they're short sleeve or whether you know that they're male. So that is kind of the nutshell of the tree diagram, and hopefully you can kind of go back and forth on this and kind of look these things through. You're doing the same one with what's it about? It's about the HIV test. You have a problem just like that with the HIV testing that you have to kind of figure out the probabilities for. So hopefully you get a chance to do that before Friday, and then you can ask questions on that on Friday.